for your presentation. Yeah.
We move now from modeling to measurements. And our first speaker is Karel Jilek from Suro, in the Czech Republic. And he will give his presentation on the testing of radon monitors in a reference atmosphere.
This here. It's mixed. Steps further. Steps. Bottom. Yeah. This is yeah. Okay. This one. Next one. How to shift? Sorry, you can move this button. Yeah. This steps forward and this button steps backward. So if you. Okay, I apologize for break. My name is Karel Jilek, and as I said, chairman. I come from Suro, where I dealing among other things metallurgy of radon, trone, and their progenies, and let's say the motivation for my presentation is as follows. The radon community adopted a reference level 300 becquerels. The good question is how and which uncertainty we are capable to measure 300 becquerels. It is important for, let's say, creation methods in different, let's say, in different workplaces and so on. Based on current practice in a relevant institution involved in radon measurements, the AlphaGuard continuous monitors play a key role like a reference instrument. Their wide dynamic range from 2 up to 2 megabecquerels, and their error analysis can indicate their operation is in both current or pulse mode. Given sensitivity by producer is 1 count per minute at 20 becquerels per cubic. Of course, question is, let's say, what is sensitivity in or equivalent sensitivity in different radon levels, and it, in my opinion, in our opinion, it makes sense to consider characteristics of this type of instruments in more detail, especially dedicated, let's say, this volume about 300 becquerels and below. That's why, like, a content of my presentation is introducing the key results of testing 4 types of AlphaGuard monitors produced in a different age and differing in internal contamination, focused on their accuracy and, let's say, precision under, let's say, close to the reference level 300 becquerels and below. And like a second, let's say, goal is, of course, to introduce a facility allowing to produce very stable atmosphere, where it's possible to compare the results with such a precise measurement like measuring instruments like AlphaGuards. They are before. That's why before the results, key results, I would like to present our facility, which are on principle based on let's say, quantities or qualities of flow sources of radium and toron sources, which they have let's say, certified or well defined, let's say, emanation power of atoms of radium and radon and thoron. And if you apply sharp and stable flow of carrier gas on the output, you can get a very well-known concentration, either or radon gas or thoron gas. So, okay, so I don't know. In principle, what you can see is on the left side. What is this? So, like a source, we use a let's say compressed air of air without radon, because it's produced via compressed air coming from outdoor air and passing let's say cylinders filled with active charcoal, which are cooled. That's why we are sure that on the output of this, let's say, low, nearly free of radon air, we have radon. It is a very important assumption of, let's say, realization of this, let's say, system. Then this let's say, radon-free air, which is pressed, is in the output, is coming to the output of flow rate regulators, Bronkhorst. And these flow regulators really allows or provides for us very stable airstream through the used sources. In the end, after, let's say, passing the source, the active air with defined radon concentration is coming to the reference chamber, which is composed from, on principle, 150 liters stainless steel can, and of course that from this chamber is possible to do relatively a lot of samples, because the lid is equipped with amount of more numbers of bushings. Air is inside is mixed, and the air from the chamber can continue to special box where another, let's say, monitor, again alpha guard or scintillation cells, can independently estimate the let's say reference concentration. Here you can see the key formula for calculation for let's say volume activity of radon. It is activity of radium-226 in the source, and emanation rate, and V is a free chamber volume. Q is flow rate, and lambda is decay of radon. During assessment, the real free volume, we calculated its volume by correction for real pressure, temperature, and relative humidity, which are in the same time measured. Here you can see real look at our facility. On the left upper side is a chamber and all, let's say, mentioned facility. On the right side of the piece figure 2, illustrates instrument for measurement relative humidity, temperature, and absolutely pressure. And what you see is a, let's say, probe for measurement of pressed dew point made from testo, produced by testo, which allows to measure low relative humidity about 0.5%. Yeah, the feature down is a part of facility which serves for us like a generator of radon-free carrier gas. Here is a view mentioned chamber with bushings. It is on the left and upper on the right side of this slide is mentioned Bronkhorst flow regulator and used pass flow sources of, in this case it is a radon source. This is an example of uncertainty budget. If we use or we test, let's say, concentration about 300 becquerels, total uncertainty. You can see in detail each uncertainty, and total uncertainty is about 2% for one K is 1 and K is a coverage factor, and the main source of uncertainty is in fact certified activity of mentioned source which provides for us a producer, and like a producer we use sources from Czech Meteorological Institute. Here you can see relatively unique results of our Toron source based on, in this case, on thorium-228, which very stable emanation power, about 89% measured, of course, high purity germanium detector. By the way, both cases, both sources was or were used during the intercomparison which organized Suro 2 years ago for radon and Toron in a mixed field for instrument under the project. In my opinion, here you can see relatively unique response. AlphaGuard in the levels about 80 becquerels, 100 and 60 becquerels, and for nearly zero activity in the tested chamber. And upper picture is for instruments measuring in 60 minutes diffusion mode, and the down sample is for AlphaGuard type DF2000 in 10-minute sampling mode. That's why the variation of responses is much higher. And on principle, what I would like to show you later is that now we can let's say compare our results, which are let's say calculated based on certified parameters of radon source and well-known flow rate, and we compare with results from AlphaGuard. On the levels, you can see a table on the left side is measured reference radon concentration and then exposition time. You can really, in our opinion, that really to keep stable 80 becquerels for 139 hours is unique, because the most of lab use only artificial air compressed, and that's why this approach allows only produce let's say steady state in the other several hours, only several hours. I don't know, maybe one day, not 140. The results, yeah, The results indicate relatively good agreement. AlphaGuard number 15, 22, and 19, 14 on the right side. It is interesting that these AlphaGuards was the older, and new AlphaGuards on the left. It means 25, 34, and 386. In other words, this is a ratio between real response and our reference volume. We calculate internal contamination each monitor, and let's say construct based on variation which we saw on our previous pictures, variation of standard deviation of measured mean volume of the AlphaGuard with respect to related to our reference concentration. It is left side. It means axis epsilon, and radioactivity concentration for all investigated instruments, and based on relatively simple formula which is given on the right side, where the AD means let's say equivalent detection efficiency, and AV means radon concentration. We was capable to recalculate let's say effective detection efficiency. I would like to remind that producer is let's say give detection efficiency 1 counts per minute at 20 becquerels. In our opinion, these let's say curves represent different AlphaGuards with different internal contamination and equivalent detection efficiencies in counts per hour per becquerel per cubic. So in the last slide represents in our opinion let's say the precision of each instrument differing in internal contamination, like a function of time at this case for 300 becquerels. In other words, if we let's say assume that AlphaGuards are calibrated very well, it means that total uncertainty to get total uncertainty, you must add relatively let's say small statistical fluctuation. It means precision, the order, let's say from 5% to 10% if we measure 1 hour. If we measure longer, you get relatively lower total uncertainties. That's all. Thank you for your attention.
Thank you, Karel, for your presentation. Are there any questions or comments? Online? No? So thanks a lot.
Thank you.
Thanks.